Can you guys see my screen?
Yeah.
All right, so not that I necessarily think this is what he's going to do, but he could do it. Right? In particular, this last property. And so just imagine if you had a problem like this. What am I trying to do? 2 to the 2000 mod 5. Is that true or false? There's no way your calculator is going to be able to take this. Right? The second you put in 17 to the 2000, you're going to get the E or whatever. So the only property I really, really recommend you guys remembering is this last one. Just take a look at this first. I even color coded it. Okay. ACN, ACN, A is raised to M. M could be any integer. C is also raised to M. Okay. If you happen to remember the other properties, fantastic. If you don't, it's not that big of a deal because you can still work this out by hand. And not really, this is not going to be problematic if you don't happen to remember it. This one could, if you could be a jerk and do this kind of problem, and you either got it right or you got it wrong because you remember the property. Okay? Yes, no, maybe so.
Yep, I'm with you.
Okay.
Yeah, I was thinking, Joe, well, you could use probably natural logs to reduce it if somebody forgets the property, natural log of both sides.
But how do you take the natural log of this?
Well, first what you do is you do 17 raised to 2000 minus 2 raised to 2000, and then
you can't do that. This is 1 unit, brother.
You move it over and then you equate them and then you take the log of both sides.
Oh, I see what you're saying. You're saying doing this. Minus 2 to 2000.
Right, then you rewrite that as 17 minus 2 all raised to 2.
Or 5K, exactly. Got it.
Yeah.
Okay, that's a good point. I just don't want that to have. I don't want this one property.
That's like an emergency valve.
Exactly.
And you can get a number out of it. Because
right.
then your calculator won't go to E. You're
Right.
taking it out.
Good point. Good point. Okay, so I had another question, and I wanted to sort of walk you guys through this. It's how to create combinations, right? So there's this idea that, one of the things that he was showing us is how to do a tree. And I suspect that if there's a problem he wants us to show work on, it's going to be one of those tree problems, right? But I wanted to show you how you can generate all the possibilities of a problem pretty easily, right? So here is my question for you. I want you to come up with a 3-character, show me all the possibilities for 3 characters for A, B, and C with repetition. Right? So you might be inclined to start with, A, B, C, and then do ABC here, ABC here, ABC here, and then offer each 9 of those. So let me show you how I would generate all these possibilities. All right, we'll start with just all the combination of 1 character. Everyone can do this, right? A, B, and C. Right? That's every possibility just for 1 character. Then what I'm going to do is I'm going to start with my first character for 2 characters. I'm going to start with my first character, and I'm just going to put A, and then whatever I have in this column. So I have A, B, and AC. Right, now I'm going to move to my next character, and I'm just going to copy this column. So this is now BA, BB, BC. And finally, with my third character, I have CA, CB, and CC. So this is this right here is every possibility of 2 characters. But I told you I wanted 3. So what do? Well, I just do the same trick, but instead of pulling from this column, I'm pulling here. So what I'm going to do is I'm going to start with A. And I'm just going to pick the first one here. So I'm going to do A, A, then A, B, A, AC, A, BA, ABB, ABC, ACA, ACB, and finally ACC. And so I'm going to move one column. This is sort of the trick. It starts with an A column. I'm going to make another column here where it's going to start with the B. Now what I'm going to do is I'm going to put a B down for every one of these lines. And I'm just going to copy the last two characters. So it's BAA, BAB, BAC, BBA, BBB, BBC, BCA, BCB, and BCC. And I'm just going to
Okay,
do this. Welcome back.
thanks.
So I'm just going to do the same thing now, starting with C. And I'm writing out a lot, but you would have to write out a lot anyways. Okay. And again, all I'm doing is I'm taking that C, I'm putting it first, and then I'm taking the last two characters of each one of these rows. CBC, CCA, CCB, and CCC. So then if I were to ask you, this is all the possibilities, by the way. I know that for certain. I don't need a tree. If you need a tree, and if that's what makes you feel more confident, I will say it's going to take you longer to do it that way, just because you have more drawing to do. But if that's what makes you feel confident, do that. I was just trying to sort of show you this is sort of how I do it. And I know for certain that this is every single possibility of three characters that have A, B, C with repetition. So then if I would ask a question like, well, what is the probability that it has one A, only one A? Well, I know this has one A, this has one A, this has one A, here, 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 and here. I think that's all of them. 1, 2, 3, 7, 11 over 1, 2, 3, 4, 5, 6. So 9 times 3 is 27. So that would be the probability. Any questions on how I'm doing this, or do you want me to do another one as an example?
I mean, I wouldn't mind seeing another one, but I think I
Okay.
get the gist of it. I like this way. Because first you
Yeah,
start off
this
with
way is much easier.
the twos, then you're
So,
essentially attributing to
how did-
A.
How did you know that it's 11?
Because I counted the red dots. Right, so I just
Yeah, but
went through my list, right, and I'm looking for which ones have an A, and so I just used a little red dot here. That I know that one has one A only. This one has one A only. So I just went through all of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right, if that was the question, I was just giving an example kind of question that we might be able to see on the test. So I'll do another one. That's perfectly fine. I don't mind. So let's do four places, heads or tails. Okay. So I'm going to start with one character. Well, what are my two choices? Just H and T. Right. How about two? Well, I'm going to start with H, and I'm going to put every instance here. HH, HT. Then I'll go to T, and I'll do the same thing. TH, TT. I know for certain, without a tree, without anything, that is the For sure, every possibility for 2. All right, but we don't want 2, we want 4. So let's go to 3. All right, so 3, again, I'm going to lead with H. All right, and I'm just going to copy all 4 of these after that H. So that's HHH, HHT. I'm doing this in 1 second. HTH and HTT. And it's only half of them. So I have to do the second half with I'm now going to lead with T. All right, so that's THH, THT, TTH, TTT. I know for certain that is every combination of 3 heads or tail flips. But let's do 4. Again, I'm going to start with H as my leading character because that just happens to, that's just the order I'm doing it in. It doesn't matter the order. So I'm starting with H. All right. So I'm going to put H first and then just copy what's in the 3 spot here. H, 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 T, H, T, oops, H, T, H, 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 T, T, H, T, H, 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 T, H, T, H, T, T, H, and H, T, T, T. Now I'm just going to do exactly the same thing, but instead of leading with an H, I'll lead with a T. So how many possibilities are there? 1, 2, 3, 4, 5, 6, 7, 8 times 2. There's 16 possibilities. So I think one of the problems in the book were how many of them have exactly 2 heads. So I'll use a different, just on this so it's obvious to you guys, I'll use another color. If I'm looking just for 2 H's and nothing more, it's here, 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 and that's it. So that's 1, 2, 3, 4, 5, 6, 6 out of 16, which is 3/8. And I would leave it as a fraction. Again, I know that's a lot of handwriting, but I do promise you, it's not more handwriting than doing, H, T, H, T, H, you're still going to have to write this list, in my opinion. And I was talking with Sebastian, the reason why this tree is so dangerous to me is when it starts to get complicated, even Professor Scholler had a problem in class where he missed 2 of them. And that's not because he's, stupid or whatever. It's when you start to get to like 3 or 4 levels out, there are just too many things to look at. It looks like a big ball of yarn on your paper or whatever. So this is what I recommend doing. Okay.
Yep, that's good.
Yeah, it seems much better than the old tree.
And again, if that's what you're more, I don't want you to be uncomfortable during the exam. To draw the tree, if that helps you keep track of it, even, right? Like, okay, what branch am I on? Whatever gets you through to the right answer, do that, of course. But I like feeling confident when I'm done with my list. I'm very confident that there's not a possible combination that I missed.
So you looked at
Obviously.
you looked at 2 heads and 2 tails?
Two heads and two tails is right here.
That's what you're counting.
Oh yes, that was one of the. I don't know if that was a study guide or if that was one of the prompts in the book.
Okay.
Yeah, talking about the study guide. That is that due tomorrow, or can that also be submitted on Friday? I mean, I'm probably gonna submit
That's due the
tomorrow,
day you
but
do the test.
gotcha.
So would this work with that World Series problem he was doing?
I don't know that problem. I mean, if you tell me what the problem is, I'll be happy to.
So Team A won the first two games of the World Series. How many possibilities is there
Sure.
after
Okay.
that?
All right. So you're saying Team A, Team B, right?
Yep. And then
And the
Team A
Team
won
A
the
won
first two
two.
games.
Okay. Win-win. Okay. So here's what I'm going to do. I'm going to do, and there's a total of 7 games, isn't it possible?
Yep. Yep. 7.
This is a little challenging because I think they would stop playing after a certain period of time, wouldn't they?
Yeah. Whoever wins 4 games is the
That's
victor.
a little, and I bet you he didn't take that into account on his problem because that would be very, very difficult to track through. But so here's what I'm going to do. I'm going to ignore the first 2 games and I'm just going to calculate 5 places. And when I'm done, I'm going to precede everything with the AA in the beginning. All right, so it's sort of like these problems, this multiplication rule or whatever it's called, the rule of multiplication, where we have only one option here. We have one option here. 1, 2, 3, yeah. We have 2 options here, 2 options here, 2 options here, 2 options here, and 2 options here. 2 to the 5th is 32. So I better come up with 32 total answers, right? Is that right?
Well, that's tough because what if?
Let me make sure I'm not. 2, 4, 8, 16, yeah, 32. But this is no easier to do it on a tree. Again, you saw it in class where
Yeah.
he was struggling to keep track of it. So here's what I'm going to do. I'm just going to do a set of 5, right? And then I'm going to precede everything with AA, right? Indicating that Team A won the first 2 games. All right, so let's just start with 2. I'm going to do this. 9. Okay. So I have AA, AB, BA, and BB, right? That's every possible for a set of 2, right? For a set of 3, again, I'm not going to change my tactic here. I'm going to start with A for the first set. AAA, AAB, ABA, ABB, and then I'm going to start with B and do the same thing, right? BAA, BAB, BBA, and BBB. That's 3. Uh,
I feel like this doesn't work for some reason because like if Team A won 2 more games, that's one of the possibilities, and then the series is over.
Yeah. So you're saying that Team A won 5 games, which is impossible.
Right? They would never play 5
So really,
games.
but I
You would
bet you
only
if
have
you look
AA.
back, I have that screenshot from. If you hold, I bet you he calculated everything.
No, well, yeah, but so the first thing he did was if A swept it, and but then he circled 1 at the top as that was one of the possibilities. So if A just won the next 2 games, the series is over, and that was one of his possibilities, and then he treed out from there. But I don't.
No,
see
so
I
how.
think what you're
he
supposed
did
to
it he
do.
did it as wrong. So let me show you. This was what he did, right? This look
Right. So you
familiar?
see the number 1. Yeah, you see
How
number
many?
1.
So
Like
hold
so,
on.
that's one possibility.
How many games did A win on the top row? That would be 1, 2, 3, 4, 5, 6, 7. So in his
No,
top
those are all
row,
different possibilities. No, those are all different possibilities.
they are not different.
So like, no, look at number 2. So number 1, AAA.
Oh, he's only
that's
stemming
the
off
series
of.
and it's
I got
swept.
it. He's only stemming off of. So I mean, here's how I would do. Let me just finish what I'm doing to show you how I would work this problem. So
Yeah,
I'm going to ignore the rule, okay, that it's only a maximum of 4. I'm just going to ignore it for the moment. I'm going to find every
Nope.
possibility, and then what I'm going to do is I'm going to strike. When I'm done, how I would handle this is I would strike the top one, for instance. This is not possible. Does that make sense?
Well, what is possible is just AA though.
No, that's why I left that.
Right. I'm not
Yeah,
trying to.
yeah.
I was just confused of how this table would work on a problem like this. I feel like it made a lot of sense for those first 2, but if you introduce something like this, I feel like it's
Well, I mean,
messy.
again, so and let me just continue the process if you just humor me, and then I'll show you sort of how I would deal with this. Right. So I have to draw a little or smaller. Let's say I'm going to ignore it. Right. You know what? Fuck that. I'm not going to keep doing this. What happened? Does that not work? Yes, it did.
Yeah, the only issue I really see is that it's going to go to at least 7 characters. Maybe that's not a huge deal, but
No, it's only going to go to 5 because the first 2 are already known.
right.
So I'm almost done. I mean, I guess, my concern about his method in class is he would have gotten his own question wrong. That's my
Right.
concern.
Yeah, I agree with that. It definitely is harder to read. I was just wondering if there's if there's a way to approach it just how he did with this kind of table but it seems like you have to kind of go through the whole
You don't have to, by the way. I mean, so I like the idea of doing this mindlessly. Okay, that's sort of what I don't want to have to think about it because my concern is if I'm thinking too hard about it, I'm going to miss something.
Right.
Right. But what do I know about this top one? I know that I don't need this top row. I don't know if can you guys read that at all?
Yeah.
Right. So I don't even need to write it. What do I know about this row and this row? A1 twice and this row. So I can put like a little check mark there. Right.
But technically with that first one, A1 5 times though. If you add if you're considering the first 2.
But all I would do is I would just move on with the ones that aren't checked. So I would do this one here. And then A, B, A, B, A, B, B, A, A, B, B, B. That one has 2. That one has 2. That one has 2. So we're only left with that one. So finally, or A, B, 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 A, B, B, B. I'm not feeling confident in that answer at all. How many did he come up with? 16?
Yeah, 16 total.
So I claim that it could be A. Let's just see if I get the right answer. Right, all I'm doing now is I'm looking for check marks. Right? I'm claiming it could be AAA, 1, 2. I don't like that order of that. I sort of fucked that up. That should have not been there. Ugh. Yeah, I don't like this at all. So I guess the tree for this one is better. I don't know. To me, it's such a complicated question that how I would end up doing this on the test, just to make sure I didn't miss everything, is I would come up with all 32 and then just take I would go through each one and I would just cross out ones that are impossible. That's how I would do it.
Okay. Yeah, I just wanted to see vision because I know, like, say I would have got that question on the test and I wanted to use the table, I feel like I would have either taken too much time or I would have panicked and felt like, this isn't how it looked in class. So I just wanted to see how you would have approached that.
And that's, yeah, I mean, I can't imagine this kind of problem is going to be on the test, but
right, I doubt it.
I think it's such a, because do you know what the easy way to do this is? Put it into Excel, it will take me literally 30 seconds. That's how fast you could do it. As opposed to coming up with 32 possibilities, crossing out the ones that couldn't be, and then counting the ones where A is the winning team, or whatever the question was. All right, so are there any questions about the study exam itself, or study guide rather?
I thought it was pretty straightforward.
I can't hear you, I'm sorry.
I thought it was pretty straightforward, but I'd like to do a transitive, like one with the
Number 3.
reflexes.
I think number 3 and
Number 3? I'll do number 3.
Yeah.
All right, did you happen to watch my video on that one, Arena?
Yeah.
So I agree that this is a super confusing one. For all
Are we gonna go through the whole thing, or are we just kind of looking at them piece by piece?
I'll do number 3. I mean, did you happen to watch any of the videos I posted?
No, I was working all day today. Unfortunately, I didn't have a chance to work on
Okay.
it.
Yeah, I thought like we'd go over the whole thing, but even I already did it, but like I thought you were going over all.
Okay.
I don't mind. I can just watch the videos.
I mean, honestly, it didn't really take me that. It honestly didn't take me that long. So, let's just do it. Why not?
What are we doing?
I'm just going to redo the study guide.
Oh, we're just going over the study guide now.
Yeah.
That's fair.
Only if m minus n. Okay. This is problem number 1. The congruence modulo 2 relation E is defined. That's defined. From the integers to the integers as follows. For all integers m and n, m is related to n through e if and only if m minus n is even. So when I say that, before I even do any of these sort of sub-problems, the first thing I'm going to do is I'm going to say m minus n is even. What does that mean? How can I write that in sort of math language? Well, a way of saying that is that 2 divides m minus n. All right? That's sort of the definition of an even number. Another way of wording that is m minus n is equal to 2k, where k is some integer. And if I was doing the exam, the things I'm writing down right now are the things you would see on my worksheet. I'm going to put this note to myself. This is what this means before I even consider what the rest of the problem is. Okay? I recommend you do the same. So the first question is, does 0 relate to 0 through E? Don't forget that the first number is M, the second number is N. So I'm just going to plug M and N here, and I'm going to try to solve for K. I'll determine if K is an integer. If it is, then the statement is true. If it is not, then the statement is false. So 0 minus 0 is equal to 2K. K is equal to 0, which is an integer. So yes, what is it? Yeah, yes. 0 relates to 0 through E. Okay, Arena, can you help me do the second one? 5 relating to 2 through E.
Yeah, so 5 minus 2 equals 2K.
Next line.
And then K is equal to 0. I meant, sorry, 3 is equal to 2K.
Okay.
And then divide by 2.
So what's K equal to?
K is equal to 3 over 2.
Right. And is that an integer?
No.
So what can we conclude?
So no, it's not.
Perfect.
Yeah.
And so how you do that is you do 5E2 and then put a slash through E. Okay.
Okay.
Next one is 6, 6, an element of E. Christian, would you help me with this one, sir?
Yeah, so 6 minus 6 equals 2K. And we got 2K equals 0, K is 0, which is an integer.
So what can we conclude?
That it's true.
Yeah. Yes. 6,
So that's
6.
how you'd write it. You'd write yes, and then.
Well, they're saying is 0 related to 0 through E? Is, so I'm just going to say yes, comma, and then I'll state what they're asking. Either this is where, you don't put the slash through for yes, you put the slash through for no. This is yes, so I'm not putting a slash through. And we'll see about the next problem.
All right.
Okay, Mr. Gray, could you help me with the fourth part of this? Oops.
Yeah, let me catch up here. Talking about the -1, 7 part.
Yep.
Yeah, so you're gonna have your -1 minus -7. You're gonna get a -8 for that, which is equal to 2K. You're gonna divide that by 2. You're gonna get -4, which is an element of the integers, which means that this statement is true.
So yes. And I'll say -1, 7 is an element of E. Okay. We cool with this one?
Yeah.
Yeah.
Okay.
Good.
Okay. This one's a little bit more challenging, but the technique remains the same. Okay. So this is supposed to be defined. Okay. So define a relation P on the integers as follows. For all M and N in the integers, M is related to N through P if and only if M and N have a common prime factor. Okay, so how I'm going to write that, just as a little note to myself, is M is related to N through P if and only if lowercase p divides M and P divides N. And I'm just saying that there's a prime number that divides both these integers. It's just a note for myself. In this particular case, we won't need it, but it's not a bad habit to get into of just writing what you know about the problem before you start asking questions. Okay? So we're asking the first part is if 15 relates to 25 through P. So what I'm going to do is, what I'm looking for is common prime factors. Well, how do we find the prime factors? We do the prime factorization of the number. So I'll start with 15. That's 3 times 5. Both of those are primes. 25 is 5 times 5. And since they both have a common prime number, common prime factor, I will say yes. 15 relates to 25 through P. Okay? All right, so we have 20, we're asking if 22 relates to 27 through P. Sebastian, could you help me with this one, sir? Okay.
Sebastian, you there?
Oh, yeah, sorry. I was muted. Yeah, the factors of 22 is 2 and 11. And then the factors of 27 is 3 times 3 times 3 or whatever.
Yep,
Yeah.
you're right.
So, yeah, so they have no common prime factors.
Perfect. So since they have no common prime factors, the answer is no. 22 does not relate to 27 through P. Okay. And now we're asking if 3 relates to 5 through P. Arena, what would you do with this problem?
So it can't be factored.
Correct. And they don't share any common prime factors. So what is the answer?
So no 3 cross P is not 5.
Perfect. Perfect. Good job. And finally, Christian, you get yeah. Give me 1 second, guys.
Go for it.
Doing a class thing?
I am.
Okay. Keep going. I'm just gonna let them walk in, no talking.
That's fine.
Eric's place.
Yeah, yeah. All right, sorry about that, guys. Okay, so we have 8 relating to 8. Well, they're the same number. So how do we handle this problem, Christian?
Yep. So like you said, since they're the same number, you can assume they have the same prime factor, and yes, 8 relates to
Perfect. Good job.
8.
Yeah, these are kind of a little trickier because you sort of freeze like, okay, what am I supposed to do with that? Good job. All right. And the dreaded question number 3. Why can't I? All right. Let me just get this problem set because you can tell a lot of the characters don't transfer. Determine whether the relation is reflexive, symmetric, transitive, or none of these. Okay. I think we're good. Okay, so this was and I was even asking in chat last night for help because I saw that in the answer key it said that transitive was no. I can answer the first 2 kind of easily. And how I normally handle these kinds of problems is I will just do a little bit of inspecting with some test problems, some test values, right? So I'm going to think about what happens when x is equal to 1. Right? Well, y can be any number greater than or equal to 0, right? for that to be greater than or equal to 0, the multiplication. For x times y to be greater than or equal to 0. Does this kind of make sense to you guys why that would be?
Let me look here. 1 second.
Well,
Could you repeat it? I'm
Yes.
sorry.
Yeah, that makes sense.
What was the point you were making? Are you just like outlining what it says in the problem?
I'm sort of outlining how I'm going to start attacking this problem, because this is not sort of clear and cut. Before we had problems, right? You guys remember this, where we had like, we could do an A, B, C, and we had like, a loop here, a line here, a line here, and a line here. That kind of
Mm-hmm.
question is very simple for us to answer. I think everyone in this room right now knows how to answer those questions without a whole lot of problem. When you're talking about all the real numbers, you can't do it quite that easily. So really, here's how I would handle the problem from start to finish. The first question I'm going to try to answer is reflexive, and that's really the easiest one to answer. And to remind you, what reflexive means is that x can always relate to x. In other words, when x is equal to 1, for instance, can y be equal to 1? Well, what happens when 1 times 1? Well, 1 times 1 is greater than or equal to 0. Well, let's do negative just to make sure that we're not doing something nuts. So what about x equals negative 1? Well, I'm claiming that y has to be negative 1 for it to be reflexive. Well, negative 1 times negative 1 is greater than or equal to 0 because it's equal to 1. And then our special case, right? X equals 0, it's neither positive or negative. Again, for it to be the same number, what's 0 times 0? Well, that's greater than or equal to 0. So I can say with certainty pretty easily that this is reflexive. Every time that there's going to be an x value, I can just instead of doing x times y, I can do x times x. I can always find that y can be equal to x, is really what I'm asking. Do you guys understand that part?
Yeah, my whole idea of analyzing this problem is that there's sort of two realms you got going on.
Positives
They're
and
connected
negatives.
by
Yes.
yeah, but it's
we're
connected
not
by
there.
the 0.
We're not there yet, though. Let's do the. I'm doing the whole
Gotcha.
problem, so you're
Okay.
absolutely right. So now symmetric. So what I'm saying when it's symmetric, right? The sort of the real definition is if x is related to y, then y can be related to x. In other words, the order doesn't matter. And that's the definition of multiplication, right, folks? It doesn't, this is the same thing as this. The order doesn't matter. For every x, there's a y. For every y, there's an x. So this is definitely symmetric. The challenging part of this problem that Greg was just alluding to is the transitive part. My initial impression of this problem was that it is transitive. And I'll explain to you why I went wrong with this. I did what I did before, where I said, what happens when x is positive? What does y have to be? Well, y has to be greater than or equal to 0. What happens when x is negative? Well, y has to be less than or equal to 0. And what happens when x is 0? Well, y can be anything. That to me is sort of the definition of transitive. In other words, I'll give you an example of what I mean. -1, -3, and -3, -5. Well, can I do -1, -5? Sure, that's +5, which is greater than or equal to 0. What if it's positive? I can do 1 and 7, 7 and 10. Right? Can I do 1 and 10? I sure can, because 1 times 10 is greater than or equal to 0. What I wasn't considering was this line, that 0 can go either way. 0 is neither positive or negative. So as a counterexample why transitive doesn't work, let's consider 1, 0 and 0, -3. Because 1 times 0 is greater than 0, greater than or equal to 0. And 0 times -3 is also greater than or equal to 0. But what about 1 times -3? What about that shortcut? Well, that's not greater than or equal to 0. So there's our counterexample. I don't know of a way of really well explaining that it's the fact that this 0 can go either positive or negative. That's the crux of why it's not transitive. We found a place where in every other step of this problem, we had positives with positives and negatives with negatives. It's in this one place where we can find a positive associated with a negative, and that breaks transitivity. I'm gonna go to the bathroom real fast and have a quick half smoke. Greg, could you try to explain a little better than I just did? Because I feel like I'm doing a half job here.
Yeah, sure, I can.
Thank you, sir.
I'm gonna open up my screen here. It's gonna be a mess.
Hey, Greg, I have to get going. But
Yeah, man. If I find anything surprising, I'll let you know.
yeah, do you want to study tomorrow?
Oh yeah, yeah, we can study.
Yeah, so I set us up in the library with the room like 10:45 with the whiteboard.
Yeah, I should be able to get there.
Yeah, but we have it to almost 1. So just whenever you get there, you can just it's under my name. So just go in there if I'm running a little late or something.
Gotcha. Yeah, man. Send me the number and I'll know.
Okay. All right. Sounds good. All right.
They'll probably
you
let
guys
us in
gonna
early.
pop into class at 12 or no? He said he was gonna like hold office hours almost during the class time.
I might ask
we
you
might.
questions. Maybe even about that baseball one. Honestly.
So I have a question for our honor lock thing.
What about it?
So the show your work, you have to submit it during the exam or after?
After.
I would do it after, just because the time you have during the exam should be to the exam.
Okay, gotcha.
And then that's even after you can like close your honor lock and then do the whole PDF and email it and then send it over to them. You probably could do it
Okay,
like
gotcha.
30 minutes to an hour later. So.
Okay.
I would try to do it within 15, but
yeah, as soon as
don't
possible.
feel stressed. So anyways, specifically about this problem, I found that Joe explained it quite well. There's this there's these two realms, and remember, this is real, so this is all the element of the real numbers. But we also have a component where we can think about it as integers. I like to think about it as integers because it's much easier and it doesn't really change the problem a whole lot. So let's say we did have this graph where we have our directed graph. That's what this is called. Make sure you're drawing these out on the exam so he knows that you're working. Let's say we have 1, 3, 10, 2. All these are interwebbed because no matter what, if we multiply by these numbers, we're going to get a positive relationship in accordance of A times B is equal to, I gotta remember, what is it, greater than 0?
Yes, greater than or equal to 0.
Greater or equal than 0. So we have this one realm, right? I understand this is in the realm of real numbers, Joe, but I'm taking it as if it was integers because it doesn't change it a whole lot. And when we say there's two realms, we mean it. There's a separate graph here that directs all the negatives. I think we all know why that is. So we can have -1, -3, if we will, -2, 10. This is why it's symmetric, because if we literally thought about this as a coordinate graph, I know it's inverted right now. Typically, this would be on the left side. This would be on the right side. But if you were to flip it, it would be exactly the same. Necessarily, if I put all the points where they're supposed to go. So yeah, all these are directed. I'm not gonna. Well, I guess I will. I'm not gonna take too much time here, but all these are directed towards each other. Just where there's lines, understand that they go back and forth. All right, and then all this, there's one realm. There's a third one where you have 0, and the 0 is kind of like the merger of the two. You can't go from here to here because there is no shortcut. 3 times -1 is not a positive real number or integer. So that's kind of what we were getting at. If this was 0, right? 3 times 0 would work. And then if you want to go to 10, yeah, that could work. Those can be interchangeable. But 3 just simply not go to -1, and -1 cannot go to 3.
That's a really good way of explaining it. I like that.
Yeah, hopefully that makes sense. The way I kind of view it, yeah, anything from here to the left can work. Anything from here to the right can work, but these cannot go from here to here. So
I like
I
that.
take it that way, I guess.
That's a really nice way of visualizing it. I like it.
Would anybody want a picture of this?
It's in the video.
Okay, cool.
Yep.
The numbers chosen are just
Arbitrary.
just because. Yeah.
Right.
Okay. Just making sure.
Yep. This could be 0.5. There could be a 0.5 over here, and the same rule would apply. Something like pi, -pi over here, couldn't connect. I couldn't get from positive 0.5 to -pi.
Right, but I can always go from -pi to -pi, or from 0.5 to 0.5.
Right. Yeah, and they can come back to themselves. Sorry, I forgot to say that these all are implied to come back to themselves.
You're right.
So hopefully that helps.
Nicely done, sir.
Thank you.
Okay. Okay, so let's move on. I think we've covered number 3 pretty well. Let's do number 4. What is that supposed to be?
Joe, are you going to show up to class tomorrow at 12 when he said he's holding like office hours type of thing?
Yeah. I mean, I can if there's a question you want me to help you go through, but no, I'm planning on taking.
I was just wondering if you were going to be there.
No, I'm going to take the test tonight.
Tonight at 12?
Yep. Okay, so this is problem number 4. The relation R is an equivalence relation on the set A. Find the distinct equivalent classes of R. So how I like to do these problems, especially since there's not a lot of things to go through, is I'm just going to do a directed graph. I'll do A, B, C, D. So we have A relates to A, B relates to B, B relates to D, C relates to C, D relates to B, and D relates to D. And let's remind ourselves what we mean by equivalence classes. What we're asking is, when I say that A relates to A, I'm saying that A sort of goes to A, right? When we're talking about equivalence classes, we're talking about the destination. So, in other words, and we're using these weird braces for equivalence classes. We're not talking about where it started, we're talking about where it's going. So there's only one point where it started. That's at A, right? Like so. And that's a set, by the way. And Irina, could you help me with B? What is the equivalence classes for B?
B and D.
Perfect. And I do really recommend that we do this in like sort of whether you do it in ascending order or descending order. Just pick an order, whether it's numerical or alphabetical, whatever. So it's easy to see which ones are the distinct ones. We'll get to that point. Christian, what are the equivalence classes for C?
C.
Perfect. And Greg, how about for D?
D and also B.
So
Or
I would,
BD, say
right,
that it's equivalent to B.
right. So we just found
B.
all of our equivalence classes, but we're not done. They want distinct, right? So I would just put it like, this, if I'm doing this on the test, I'll put distinct. A is not related to any other set here, so I'll just rewrite that. A is equal to the set containing A. Right? But B is the same as D. So I'm going to say B is equal to D is equal to the set containing BD. B and D rather. And finally, we have the set C, and that's just the set containing the element C. Okay?
Would I get points off for saying D is equivalent to BD?
Say that again,
Or should I
please.
just have it? Would I get points off for saying that B is equal to BD and D is equal to BD?
Yes, you would.
Instead of, okay.
And that's because they're looking for, he says specifically distinct.
Gotcha. So for any time, if it doesn't say distinct, I can have it the other way, or can I also do
Yeah,
it the
if
way
it
you
didn't
just
say
did?
distinct, you could leave it this way.
Okay, but
It's
like,
going to, I
let's
promise you
say,
on the test, it's going to say distinct.
okay, even if it's not distinct, can I do it the way we just did it?
Yep, absolutely.
Can I just leave it at, you know what? No, I'll just do it the way you did. Yeah.
Yeah, I think honestly, no matter how he words it, really this is what he's looking for. He's looking for us to identify that the what the equivalence class B is equal to the equivalence class D, which is equal to a set containing B and D.
Mhm.
Okay.
Gotcha. Cool.
All right. Where are we at? Number 5.
All right. So this is an extension. What extension is that?
What?
Yeah, that's pretty cool.
What's that?
You had an extension to your Chrome browser.
Yeah,
It's
your
not
browser
familiar with.
I don't know.
Keeping his secrets from us.
Looks like a movie theater or something.
Oh, this? Yeah, don't worry about that.
Yeah, that.
Yeah, don't worry about that.
Is that something you made?
No.
No.
All right. All right, so number 5, which of the following congruences are true and which are false? Right, so as just a small reminder, how I read these, right, is, and I'll just write it generally. When I say A is congruent to B mod C, I sort of view this symbol here, this weird equal symbol, as an equal symbol with an extra subtraction symbol, and that's what reminds me of the order. Right, so what this is equivalent to is A minus B is equal to C times K, where K is an integer.
Yeah, just a real quick question, Joe.
Sure.
We've been doing it where it's congruent to something for so long. What if it was just 3 mod 4 for the first one? Because I've completely forgotten just how to do that. I've been doing the congruence for too long.
Well, that has to be related to something. So the one that I don't know how to work, and I guess we can try to do it together, is this. A mod B is congruent to C mod D. And he even said he's not going to explain that one in class.
Yeah, we don't have to talk about it. That's not the case.
I honestly don't know how to make heads or tails of this one.
Okay. But if it was 3 mod 4, what would the answer be? What would
That's
that
not
be?
related to, so that's, when you say,
Wouldn't we get a remainder though?
no, so the thing that changes, so there is a way of sort of counting in modular arithmetic, but the thing that changes is this second digit here. Okay, so let's just cover that real fast, what that might look like. Okay.
Okay.
So we have 5 is congruent to 0 on 5. And so what that really means, right? Just to remind you guys, 5 minus 0 is equal to 5 times k. Right? When I increase this number also must increase. Or I could say, the other thing I could say here, so there's a few things, it's a few directions I can go here. If I'm trying to add to this, I can either say, well, what happens when I increase this first number by 1? Well, that leaves me with this sort of equation, right? So I'm asking 6 minus x is equal to 5k. And so I need, this is sort of unintuitive to me, but this needs to be 1, or it needs to be 6, or it needs to be what, like some 5, there has to be a 5 plus 1 here, right? So this is going to be 1. Okay?
Yeah.
Another way of sort of adding on to this is say, what happens if I add on to this last digit? Okay, so I'm going to say mod 6. Let's say I left the first digit the same. Right, so what I'm asking is 5 minus some integer is equal to 6 times some integer. Right, so what I'm looking for is sort of, where do I have to end here? Like, what do I have to subtract to get to an integer, or a multiple of 6? And the answer here would be 5, because 5 minus 5 is 0.
Yeah. So I think I figured out my question, and it might bring a little bit more of a understanding, I guess.
Okay.
3 mod 4 means you have a remainder of 3. Because 3 divided by 4 leaves you with 3 over 4. You take the top number, that's 3. The reason we subtract 3 to 91 is so that we get rid of the remainder of 91 divided by 4.
That makes sense. Okay.
Yeah.
But I honestly don't think, truly, I don't think that this has any meaning by itself.
I was talking with a friend of mine from UCF, and he says that,
That has meaning?
and he might be wrong. It does have
No.
meaning. Yeah.
Okay,
Yeah.
I don't think we've covered
But
in class. How about that?
I don't think it has meaning towards this class. Yeah, I don't think he'll ask a question where that equals something. So, I didn't know if that was something. I wanted to get your opinion on it, see if it's something we need to know.
No, I don't think it's something we need to know. But
Okay.
I do think that you're right. So I mean, one of the things we covered a couple chapters ago was this, and let me see if I can remember the numbers here. It was something like this: n is equal to dk plus r, right?
Yeah.
Does that sound like about right?
Yeah, that's right. That's right.
So I think you have the truth of it, that when I say this first number is actually n, and this second number is r, and the third number is d, I think.
Do you guys have to throw me off the day before the exam with all this theory
Ignore this.
crafting?
I'm sorry, dude.
You don't
Yeah,
need this.
yeah,
Sorry,
yeah.
this
I'm
is
just,
all
We
I'm
just
just
for
sort of,
me.
yeah. I'm sorry, dude. Don't worry about it. Ignore what we just did. Let's just answer the
Yeah.
questions.
I get it, Joe. Thanks.
So 91 is congruent to 3 mod 4. And so I'll just do the first one myself. So again, this is subtraction sign. So I do 91 minus 3. What's going on? Huh. It froze. No, it didn't. What the fuck? All right. Well, fuck you too.
You broke the whiteboard?
I did. All right. All right. So let's see. No, it's still not working.
Telling you, it's all that theory crafting. You and Greg got too deep. The board couldn't handle it.
Yeah, it exploded with all of my big brainness.
Huh. All right, let me
Couldn't
unplug it real fast. Plug it back in.
Have you
Worst
tried
case
asking
scenario,
it nicely?
you can always fall back to paint.
Yeah, now that I'm
You were
starting to
pretty
get used to
good on
this,
paint.
yeah, it'd be better than I would be. If you think I draw bad with the drawing pad, don't worry, it gets worse. There we go. All right, so this is 91 minus 3 is equal to 4K. 91 minus 3 is 88 is equal to 4K. So K must be equal to 22. And since 22 is an integer, then this is correct. So I would say which are true and which are false. So I would say true. 91 is congruent to 3 mod 4. Is how I would write that in the test. Okay. All right. Second one is B. 88 is congruent to 5 mod 6. Arena, could you help me with this one, please?
Yeah, so you do 88 minus 5
Sorry.
equals 6K.
Perfect. Next line.
And then that would be 83 equals 6K.
And you can do this on your calculator, but this is not an integer, and it does
Okay.
not reduce. Right? So
Okay.
you can sort of know that in your head. 6 goes to 8 once with 2 left over. 6 does not go into 23. Right? So I'm just going to
Okay.
put 83 sixth. And since that is not an integer, then I will say B, false. 88 is not congruent to 5 mod 6. Cool?
Yes.
All right, we have C, we have 119, oops, congruent to 0 mod 7. Christian, could you help me with this one, please?
Yep, so since it's 0, you just got 119 equals 7K. Which I'm guessing is not an integer. And I was wrong,
Okay.
it is 17.
Yep. So C would be true. 119 is congruent to 0 mod 7. And last one is 235 is congruent to 3 mod 13. Greg, if you would.
Yeah. See here. I think we got 232 divided by 13, which I think is equal to 17 with a 5 over 7 remainder.
Yeah, so that just means we don't, so that's 13K.
Sorry, I'm skipping logic. Yeah. I'm thinking here. Sorry, I'm more.
So since 13 is prime and we know it's not divisible, we can just say 232 over 13. We can just leave it like that.
Gotcha.
And so
Am
that's
I right though? Is it a
I don't know
I
what the
think it's
number is. 13
17.
goes into
I don't know.
1. So so it's just under 13. It's like 12 and a half. Am I right?
I don't think so, because
It's about
it's a
12 and a
little bit
half.
under 20. It's about over 20, under 20 actually,
No,
because
okay, let's do it.
20 would be 260.
Hold on.
Subtract
232 divided by
2 and some from
13
that.
is 17.8. What did I say?
Ah, I said 17 and then a remainder of 5 over 7.
Oh, because yeah, you're right. I messed up.
Ah,
That's
I
what you
have
get
no
for
idea.
trying to do shit in your head. All right.
As I do shit in my head.
All right, number 6.
That's when you say weird flex, but okay.
Nice. All right, so I'm not even gonna, I mean, this one should be, does anyone not know how to do this problem?
I do. It's just I had trouble bringing up the fraction for it.
Okay, so let's do it. So here's what we're gonna do. We're gonna create a table. What they're talking about is this sum, right? And we have 2 dice. So I'm just gonna make a little table. 1, 2, 3, 4, 5, 6. Oops. Four. Perfect. All right, and so what I'm gonna start with is I'm gonna start by putting my values for one dice up here, right? So how many values, Arena, of dice can there be on the first dice?
6,
So what would I put in the first column here?
1.
Right, and then just 2, 3, 4, 5, 6, right?
Yeah.
And then I'm gonna do the same thing on the rows here, because this is the other dice. And now for every square, I'm just gonna add the 2 numbers together, 1 plus 1. That's 2. 1 plus 2 is 3. 1 plus 3 is 4, 5, 6, and 7. 2 plus 1 is 3. 2 plus 2 is 4, 5, 6, 7, 8. 3 plus 1 is 4. 3 plus 2 is 5, 6, 7, 8, 9. 4 plus 1 is 5. 4 plus 2 is 6, 7, 8, 9, 10. I shouldn't have done that. Here, I'll do it this way.
I'm back.
Welcome back. 5 plus 1 is 6. 5 plus 2 is 7, 9. Oops.
You want me to show you a shortcut?
What in Excel?
That, and then also, if you go diagonally, you just follow the numbers diagonally, you get the
Yeah.
same
I'm
number.
just trying to. Yeah, I know what you
Show it?
mean. Yeah,
Yeah, show
exactly.
how it works. Gotcha.
All right. And again, we're just confirming that 6 plus 6 is equal to 12, so we're spot on. All right. Now, my first question for you, Arena, is how many different possibilities of the sum are there? Well, we're rolling one dice for 6 times, and we're rolling the other dice for 6 times. So how many total
6 times 6.
possibilities? Which is
6
what?
times 6 is 36.
Perfect. Now, we were asking for the sum has to be equal to 10, right? Well, we have a 10
Yeah.
here. We have a 10 here. We have a 10 here. Those are the only 10s on the board. So we have 3.
Okay.
3, and so we just reduce this fraction. 3 divided by 36 is 112.
Oh, I got it. Okay.
Cool?
Yeah.
And finally, number 7. Okay, so we don't need a tree. We don't need all the possibilities here, right? What they're looking for here is for us to sort of consider everything here, by the way, is a length of 5, right? You see all 3 parts of this problem are a length of 5. So I'm just going to put 5 blanks. And we're being asked how many bit strings have length 5. Okay. So this is the first, this is the second, third, fourth, and fifth. And so, Christian, what possible characters can go into this first slot?
Either 0 or 1.
Right. And that's true for everything here, right? For part A. Right? So for every single one of these, it could be either 0 or 1. And Greg, how many options is that?
Probably something like 2 or something like
2.
that.
Yep.
Maybe 3.
What a genius.
Thank you.
Oh, sorry, I wasn't trying to be. So how we figure this out, and I want, if you guys take statistics later, the thing that you'll sort of end up remembering is that when you go vertically, you add. When you go horizontally, you multiply. If you take statistics later, you'll know what that means. You're doing complicated trees and shit like that.
Yeah, by the way, don't take Professor Condor. Very tough instructor. Not very forgiving. Also, he is very unorganized, so just don't take that professor if you're taking statistics.
So since we're going horizontally, we're going to be multiplying 2 times 2 times 2 times 2. That's equal to 2 to the 5th, which is equal to 32. Okay? Now let's do part B. For part B, it's how many bit strings of length 5 begin with 3 zeros. So Arena, how many options do we have for the first place?
2.
It says how many bit strings of length 5 begin with 3 zeros. So what can the first place be?
Begin 0.
Right? It can't be 1, right? The second
Yeah.
place has to be 0. The third place has to be 0. And then it didn't say anything about the fourth and fifth. So this can be either 0 or 1. 0 or 1. So now let me re-ask you. How many options do we have for the first digit?
We have 1 option.
Correct. And for the second?
1.
Third?
1.
Fourth?
2.
Fifth?
2.
And so this is equal to 1 times 1 times 1 times 2 times 2, which of course is equal to 4. Cool? Questions?
No, it seems real straightforward.
All right, you're up, Mr. Christian. How many bit strings of length 5 begin and end with the 1? So how many options do we have? What options do we have for the first place?
So since it's going to begin and end with a 1, the first and fifth only have 1 option.
Correct. And how about the second,
2,
third,
2,
fourth?
and 2.
You sure about that?
And so this is 1 times
Maybe
2
3.
times 2 times 1. And that's, of course, equal to 2 to the third or 8. And that's it.
My question is, this all seemed extremely straightforward. The transitivity one was a little confusing. I kind of am having some problems, like really getting that in my head all squared away. But everything else seemed so straightforward that I'm kind of worried. Like I
Yeah,
haven't
I'm the
gone
same
into any
way.
of the
I'm the same
homework.
way. Yeah, because, dude, the
Uh,
last time we had problems, I felt, and look, I'm not trying to complain. I'm glad that we have the teacher we're having, so don't, I'm not trying to be a jerk. But I felt kind of like ambushed the last test,
right.
where
That's how I felt as well.
where there was stuff on that test that I did not see coming. And don't take this in a shitty way. If I don't see it coming, I promise you, I spend hours every day going over this stuff, making sure that I can sort of communicate it good to you guys. If I'm not seeing it coming, I'm sure you felt like, well, what the fuck am I supposed to do with this? You
Right.
know?
Yeah, I didn't look at any of the homework, unfortunately, so I was only going off the study guide, what we were reviewing. I got into that test and felt like there was a lot of stuff that I didn't even know how to really begin
Right.
with
Right.
messing with, which is my own fault for not going into the homework and doing more, which I'm sure deep in the homework there's some similar problems
But
to
then
what
he
we had on
tells
the
us, and
exam.
it's weird. He's kind of weird, man, because he said like only do 1 through 13 of the the congruence modulo problems.
Mm-hmm.
Just FYI, go pick up an elementary mathematics book of like a postgrad class. I want you to guess what they start with every single time for like set theory, number theory, graph theory. Where do you think they start?
Modulo arithmetic.
Congruence modulo. Did I have a bookshelf of books, all postgrad? I promise you they all start there. It's very weird that he's like, yeah, this is not a big deal.
Right.
Like, okay, I'm not complaining. I mean, just
Yeah.
as you
Because
saw
I
it,
mean,
me and Greg were going over it. Like, I'm not sure if this means what I think it means. Like, it's a deep topic. And if he
right.
hits us with something where it's like, 5 mod 4 is congruent to 6 mod 7, I'm going to go, what are you talking about?
Right, that's what I'm worried about. Like, if you're going over the mod ones and they're just so simple, I feel like there's got to be
Yeah.
something
Well,
else
he
he's
even
going to
You
said,
know
throw
don't
in
what,
there.
Joe?
do the other
I
thing
think
about
that.
that. Hold on, let me just say one more thing about this. He said
Yeah,
only
go
do
ahead.
1 through 13 in the problems in the book. Go look at problems 1 through 13. Over half of them are proofs. Over
Mm,
half. And not
Yeah.
easy proofs, like things that I have to like really rack my, and again, I'm not trying to say I'm better or worse. Just I found them very challenging. And I'm thinking to myself, is this going to be on the exam? Only problems 1 through 13? So I have the same worry you do. And I'm not gonna give you guys answers or nothing, but I will probably say something like I felt ambushed again, or I felt prepared for the test.
right. Yeah, that's where I'm just worried. Just because based off of the study guide you just went through the past couple days of sessions, I feel like I understand all the concepts. But then if I opened up the exam right now and I was to have to write a proof on any of this stuff, I
The,
would
the,
be
the
just
proofs, yeah,
lost on a raft.
and because what I was doing with Sebastian and Greg is I was going over only the hard problems in the homework problem. Like they put an H next to the problems that are hard. I'm here to tell you that the
Right.
problems were really hard. Like,
Mm,
so, I don't know what to expect. Because I mean, the other thing is, how do you do a proof on honor lock?
right.
You know,
I have a feeling he's going to be a little nicer to us because this is the first time a lot of us will be on honor lock. But I don't know. I'm just worried that there's concepts I'm missing because
yeah,
if
I'm
it's
saying
just
I feel the same way.
like this,
I feel the
then
same way.
I feel super confident.
And
But
that's why I want to get out of the way. The second that thing is up, I'm going to be taking the test because I don't like shit hanging over my head. I don't deal well where it's like, okay, wait till Friday. You're like, no, let's go ahead and just get that done now.
Right.
Yeah. So, in terms of A mod B is equal to C mod D, from my understanding, it's kind of what we just went over, Joe. What is 3 mod 4? Well, it's 3, right? So I think that's how that's supposed to be done. Like, what's 9 mod?
Let me try to think. Hold on, I have to sort of process.
What's 9 mod 6? That's 3, right? We have to
9
think about that
mod
in that
6.
way.
So let me just
Or
put like
9 mods, yeah.
So I would say that is x is equal to what the fuck is going on with my pad?
Also, I'm not at my computer. I'm walking around right now, so I'm not seeing what you're seeing.
It's gonna piss me off if this thing breaks. Huh?
You get what I'm saying?
Yes.
I think that's how that comes into play. So hopefully, if he does have something like that, it's not a complete surprise. Maybe there was another, like maybe he didn't want to get into it because it could have non-integers in it, or maybe it's a little
No,
bit more
but
complex.
modulo is not a continuous function too. So that's the other part of this that's I don't think it is. Or if it is, it's governed by a function I've never heard of.
Yeah.
So let me just go through this. So if I say that 9 mod 6, what am I really saying about that? I'm saying, let's say n is congruent. So that n is equal to plus 9. Yeah, that's right. So 6k plus 9. Okay, so what was so you're saying 9 mod 6 is
3 mod 4 is congruent to 6 mod 9. Or sorry, 9 mod 6.
3 mod 4 is congruent to 9 mod 6, let's say. Okay, so let me just think about what that means.
So that means you have a remainder left over 3.
So 9 mod 6.
So you're not worrying about what's divisible or
is
divised
equal.
by, you're worried about what's left over.
So this is the remainder plus 3. This is the multiplier. All right, so now let me reverse it. I just have to work through it to try to understand.
Yeah, go ahead.
So this is the remainder plus 9, and this is the multiplier. But it's not the same.
Like I said,
it would be
see what you mean.
6L. Okay, I mean, that's still not solvable, but at least I have a system of, I have an equation for it. And the reason why it's not solvable is because you can't assume that the multipliers are the same number. If you could assume that, then maybe you can, and I just don't know that.
Yeah. Maybe you have to prove that. Maybe there's a way to prove it that we just don't know.
Exactly.
Maybe that's why it's so complicated. Yeah.
I mean, if there's a way of like forcing, instead of this being L, if there's a way of forcing that to be K, then this is simple, right?
Right.
2K is equal to what? Minus 9 is negative 6. K is equal to negative 3. And then just plug it back in to generate numbers. I think. I don't know.
It's not important. If he says it's not important, I hope it's not. If it is, I'm going to be upset.
I promise you, because he actually I have it on my paper. Here, let me just go over it because I turned to that page. Let me just say.
Because his definition is the remainder after dividing one number.
So he gave us 5 equivalencies. So I'll just write them out and then let's see if that helps us, okay? So we start with n times a minus b. A is congruent to b mod n. A is equal to nk plus b, where k is an integer. A, this is the one that I struggle with. A and B have the same non-negative remainder when divided by n. And finally, and this is the one I didn't understand, A mod n is congruent to B mod n. So those 5 things are equivalent. Now let's see if we can work it out. Yeah, I don't know. But he started explaining this one and he stopped himself.
What's that?
Can you see what's on my screen?
I can't. I'm still away from the computer. I'm in my car cleaning stuff out.
Okay. Anyways, does anyone have any other
Um,
questions about the
I can
test
hear what you're saying.
or the study guide or anything else in the homework that didn't make sense?
Anything in particular that wasn't in the study guide you'd suggest I go look at?
I put up a screenshot in general, just that last property. Try to keep that last property in mind. I mean, honestly, we have covered this material, especially the people in this room right now. We have covered this material, I promise. And it's not like I've been cutting corners. So I,
Right. That's what's worrying me. I feel like I'm too prepared right now.
I hope.
But
Isn't
then
that
I
a good feeling though?
No, it's a
right,
horrible
but then I
feeling.
feel like I'm gonna
It
get
feels like
sideswiped.
that's right. That's right.
Okay.
Yeah, I don't like the feeling of feeling
Not
too
knowing what's gonna
prepared
happen. Yeah.
because, and really, it has to do with the last exam because I felt really prepared going into the exam until I saw the test.
Right.
All right, guys,
I
I'm going to
guess
go ahead and
we'll
at least
see.
end the recording here, and I'll post this to
Okay.
YouTube.